Welcome to the Ultralight Airplane Workshop. My name is Leon. You found part 2 of the multi-part series of making the molds for the rudder of the UWS-1 Ultralight Airplane. In part 1 of this series, we talked about the overall plan for how we're going to make the molds for the rudder. At the start of this part, I'm going to kind of review that just a little bit. And in particular, we're going to talk about making the molds for the surfaces of the rudder using this plug. And there's a whole series on making this plug, and I'll put a link to that up here in the upper right hand corner. For making the surface molds, what I want to do is have a flange all the way around the surface. And it's going to be two-part surfaces. There's going to be a mold for one side of the rudder and then a mold for the other side of the rudder. Now there's a little bit of overlap here on the nose, so those molds will actually extend past each other. We'll only use one at a time. We won't use them both simultaneously, so that's not a problem. Now I want to get a flange all the way around the edges. That's because I want my carbon fiber to extend just a little bit past the edge of the mold so I can come back and make a nice clean edge. And I need some room to put down my tacky tape for my vacuum bag because we're going to use vacuum resin infusion. Now on this trailing edge and on the leading edge, I bought some material from Composite Visions. And by the way, they are not a sponsor of the video. I bought this using my own money. But this is plastic that's 6 inches wide, 48 inches long, and about 1/8 of an inch thick. But you can see it's pretty flexible. Now if I was only making a mold that was about up to here, this is flexible enough that I could actually make it form to this curve fairly easily. But this nose curvature is far too much to try to make that go around this nose. So what I need to do is extend the plug a little bit further. And that's what this video is going to concentrate on, is how to make a plug a little bit further. And the reason I'm concentrating this video on making these plug extensions is the process for making these extensions, at least here on the bottom and at the top, is going to be very similar to the method used to make the plug. But I'm altering the process a little bit, do some more experimentation. So I'm making this video to talk about how I'm doing the extensions a little bit different than I did the plug. But to go a little bit more into the plan for part 3, is I'm going to use this material here on the trailing edge, and it'll come up tight against this trailing edge. Now since this material is so flexible, I'm going to have to come up with a way to support it from underneath. But the carbon fiber will come over past the trailing edge, out a little bit onto this plastic, and then tacky tape will come around that up onto this plug extension, and then on the leading edge. So like I said, we're going to wrap around here quite a ways, about 1 inch from the very leading edge, because the overlap on the parts will be about 1 inch. And then this part will come up here at about a 90-degree angle to that. See if I can get it in here. It's going to be kind of floppy. That's close enough for the moment. This will actually be up more like that. But as you can tell, this is going to be a fairly sharp angle here. So what I will do is I'll put a fillet in here with some of this clay. And don't even ask me to pronounce it because it's French. It's a plasticine. I also got this from Composite Visions. So what I'll do is put a fillet about a 1/4 inch radius, maybe up to about 3/8 of an inch radius all along here, so that carbon fiber can make that bend. Number one, so I won't have any voids under there that'll get filled with epoxy and waste of epoxy. And number two, I won't be breaking the fibers in the carbon fiber. Now that part in here where the bend is will end up getting cut off, so that second part really isn't as important. So in the long run, it's probably good practice for me to learn it and do it even when I'm making these molds. So again, this will come out to where the plug's going to be on the top end and the bottom end. I want to take a quick moment to thank the patrons of the channel on Patreon. We've got 2 long-term patrons at the designer level, Richard and Keith. And we have a new patron, Ryan, at the early bird level. Now Ryan gets access to videos about 5 days before they go public. Designer level patrons get that also. They also get data files I used in creating the UWS-1 Ultralight Airplane. They get tutorials for software and tools I'm building. They get videos for tools that I've built. And at some point, I'm going to start doing a few live streams. So they'll get access to that too. Let's get to the details of making these plug extensions. I said that making these plug extensions was similar to the way I made the plug. And that's going to start with some templates. I need one template for each extension. I use Fusion 360 to make my templates. And this is basically a view of looking at the plug from the top. So this is the very top of the plug, and out here is the very bottom of the plug. So I can just print this out twice. I can cut out this template for the top and this one for the bottom. To get the right size for these templates, I removed 30 thousandths of an inch from what the desired size of those templates would be. In other words, the fiberglass I'm going to put on these templates is going to be about 30 thousandths of an inch thick. So I removed that from the overall dimensions to get this template size. And I had to scale this drawing just a little bit because my printer prints a little bit too small. So the scale is 1 to 0.988. And just to verify that I got the correct dimensions, I put a dimension on here. So from the nose to the trailing edge, it's 9.714 inches, and I verified that that's pretty close to correct. And I also verified this longer one down here. So I print these out and cut them out. Right up here you can see that I've already cut out and applied the bottom template to a piece of 1/8 inch thick plywood. And this is something that I'm doing different than when I made the templates for the plug. When I made the templates for the plug, I used epoxy to glue the paper down to the plywood. And then I had to wait for 12 hours for it to cure. That's because the type of epoxy I used. So that used up pretty much a whole day. And I didn't want to take that much time this time. So this time around, I'm using some general purpose 3M 45 spray adhesive. I spray it down on the back of the paper, and I flip the paper over and attach it to the wood. And later, after I've glued the wood to some foam and hot wired the foam to the correct shape of the template, then I'll remove the paper. I did not do any experimenting with cutting it out this time. Just used the bandsaw to cut it fairly close to the line, and then move over the disc sander and sand right down to the line. I want these plug extensions to be 3 inches long. I happen to have 1.5 inch thick foam, so I need 2 pieces to stack together. And there's no need to waste time hot wiring these out to rough dimensions. I just got a razor knife and cut most of the way through it and just snapped it in half. Quick and easy, easy peasy. To glue my 2 pieces of foam together and to glue the template to the foam, I'm going to use 5-minute epoxy. I really don't need to have a fantastic bond here. I just need to have it hold together under just normal handling conditions. And the 5-minute epoxy, after about an hour, it's ready to use. It really isn't ready to use after about 5 minutes, but after an hour, it's ready to use, so it's not a bad epoxy to use for this kind of application. I draw an outline of the template on a middle face, the face between the 2 foam blocks, so I can get an idea where to put my epoxy. I try not to put too much epoxy on because I keep trying to have excess epoxy that's going to squeeze out where I'm going to hot wire cut, because cutting through that epoxy is a little bit tough. It kind of distorts your shape. Although in this case, it doesn't really matter if it distorts it a little bit. I only care that the very edge where the airfoil is gets the correct shape. But it always squeezes out and always end up cutting epoxy. I also put epoxy on my template before I put it down. So I stack the foam together, I put the template on top, and then I put weight on it and let it cure, like I said, for an hour. And then I can hot wire cut it. I didn't have anything new to try while hot wiring out these extensions for the plug. Basically, I did it the same way I did the foam for the plug. Hot wiring through epoxy causes a little bit of problems. You're not going to get a really smooth surface. That epoxy kind of spreads out and melts, so you have to sand that off to get a nice clean joint. And the epoxy tends to make you speed up and slow down as you're hot wiring, depending on whether there's actually epoxy there or not, or how thick the epoxy is. And so that tends to make an uneven surface of the foam also. So I sand that down to get a nice smooth surface. One of these days I'll get better at using less epoxy so it doesn't squeeze out and cause me problems. So here's a continuation of one of my little experiments where I used spray adhesive to hold the paper down for my template. Since this face of the extension is going to be given a really smooth finish with a surface release, I can't really leave this paper on here. So I'm going to peel off the paper, but I'm going to leave any adhesive that's still kind of stuck to that wood on there to see if it causes me any problems. Here's another slight difference I'm going to do compared to the way I did the plug. I'm going to use Drywall Mud again to fill the pores and deep holes in the foam. When I did this on the plug, I used a pretty thick layer, probably about a 1/16 of an inch thick, and I sanded that all down until I could just start seeing pink. I'm not going to do that this time. This time I'm just putting a skim coat on the places of the foam where I think I have a pretty good surface already. I'll still, though, use whatever thickness I need to fill gouges and cracks and nail holes and such. Well, this time sanding is a whole lot easier. On the plug, I had roughly a 1/16 inch of drywall that I wanted to sand down. And I sanded that down until I could just start to see the pink foam. In this case, it's much simpler. I'm just sanding down the high spots. I'm not trying to sand down to where I just start to see the pink foam. So this is much faster, and I think this is probably the way I'll make plugs from now on. Doing that thick layer of drywall and then sanding it down to where I saw the foam took a long time. And I think it probably gave me a pretty good finish. But I think that trying to get that smooth finish here at the foam stage is probably not the right thing to do. I think trying to get that smooth finish should occur after I put the fiberglass on. Handling this foam too much is really dangerous because it's very fragile. And I found when I was doing the plug, I was constantly have to go back and fix little dents and dings and scratches that I was putting into it just from handling it. So I think I'm going to like the skim coating and then just lightly sanding down the high spots much better. I want 2 layers of fiberglass on my plug extensions. Basically, I'm doing the same thing that I did on the plug. In this case, I really don't care which direction the orientation of the fibers are. It's not a structural piece, it's just a simple plug. The only purpose of the fiberglass is to give me a fairly tough surface that I can use in laying up the molds. Now this part of putting the epoxy and fiberglass on the plug extensions is very similar to the way I did it on the plug. I put down a layer of resin, let that soak into that drywall mud because it soaks up quite a bit of resin. Then I put down my 2 layers of fiberglass, soak them up with resin, and then I did do something a little bit different. I tried to put extra resin on the surface of the last layer of fiberglass just to see if I could fill that weave in just a little bit more so it wouldn't need quite as much filler. Although I kind of screwed up and had a problem. I should have just not bothered with this little extra step because my epoxy had started to set up and it started to gel and getting really thick. And so I ended up putting way too much epoxy on that I had to end up sanding off because I was getting these kind of puddles and ridges that had built up just because the epoxy had thickened so much as it was curing. After about 5 hours of cure, I went back and trimmed off the excess fiberglass. I really liked that from when I did the plug, so I did that again here on the plug extensions. Then we let it cure. Just in case there's some amine blush on these epoxy surfaces, I'm using some denatured alcohol to wipe down all the surfaces where I've applied epoxy. So that's going to be the side that I sealed with epoxy on the template and on the flying surfaces. The other side, the side that's opposite the template, is just bare foam, so I haven't done anything with that. I mentioned before that I put a little excess epoxy on this fiberglass, and so I've got some high spots now, particularly where there's a little bit of sagging or where there's just plain excess epoxy. So now I'm sanding that off. I'm using some 100 grit sandpaper here on a fairly flexible sanding block. So I'm going to get rid of these high spots, and then we'll start filling in some low spots. Now here's another little experiment I wanted to try. Composite Visions had this epoxy tooling dough, or tooling putty. And I wanted to see if this would work as a filler on the fiberglass. Now you see the way I'm mixing it here? Don't do what I did. This is a terrible way to try to mix it. It just does not work. Now, a little bit later, I tried another way, which is just to put it in your hand and knead it. And that actually worked out fairly well. It still kind of left little micro parts of the white portion of the epoxy, not quite broken up. So it would take quite a bit of kneading to get it all mixed up. But kneading it is way better than trying to do what I did here. Here's my first attempt at trying to use this tooling putty as a filler on the weave of the fiberglass. And I found out very quickly that this putty is really too dry to really use in that application. It doesn't want to fill in fine details like the weave of the cloth. I think it would be fine for really large holes, 1 inch diameter and fairly deep, something like that, where you can really stuff it down in there. But it's so dry that you can't get a smooth finish like you can with the drywall mud. So for this particular application where I'm trying to use it, I just don't think it's appropriate. But I went ahead and finished trying to fill in all the surfaces with it just to see how it would behave when I went to sand it. After I finished doing that filling, I wanted to learn a little bit more about the properties of this putty, so I picked it up and started playing with it. And that's where I stumbled across the idea that, I think kneading this would actually be a good way to mix it. So a little bit later on, I tried that and I was pretty happy with the kneading method. But I was also here trying to figure out some other experiment that I could do with this epoxy. Try to learn a better use for it. For my molds, I'm thinking of using this 3/4 inch foam as a stiffener. So the edge of the foam would go down against the mold, and then I'd cover this foam with fiberglass. And that would be to make my mold stiff. But I want some way of gluing the foam down to my fiberglass mold. So here I'm going to use this putty as a filler between this 3/4 inch foam and my mold, which is the 1.5 inch thick foam here in this case. And then kind of press it down and squish it out, and then try to use my finger to make a B down in that 90-degree angle between my stiffener and the mold to help the fiberglass I'm going to put over the stiffener come down around that corner without bunching up or creating voids or whatever. For this particular application, I think this tooling putty is a pretty good method of filling voids between the stiffener and the mold and then making that little curved bead down in there. Although I had determined that this putty wasn't really the right material to use to fill the weave of the fiberglass, since I'd already put it on, I wanted to see how well it sanded. And I would probably compare it to epoxy filled with glass beads, as a method of making the epoxy lighter. I'd say it's about the same hardness in sanding. So it wasn't easy to sand, but wasn't necessarily difficult to sand either. Kind of in between. By the way, I think that putty worked great gluing down my foam stiffener down to my pseudo mold top, in other words, the 1.5 inch foam, and pushing in and making a little bit of a fillet there for the fiberglass to go over. I think that worked out pretty well. Here's an additional experiment that I wanted to run. I wanted to try some of this West System 410 epoxy filler. It's a filler you're supposed to use in epoxy to create an easily sandable faired surface. I end up mixing this about 4:1 by volume. I think I should have gone just a little bit thicker, and I'll explain that just a little bit later. This filler is made from a thermoplastic, and you're really only supposed to use it with epoxy. You're not supposed to use it with a vinyl ester or like polyester, because solvents in those resins can attack this filler, and you get the same kind of problem with paint. Some of the solvents and paints can attack this filler. So you're supposed to put something similar to an epoxy layer or something like that over the top of this before you put something else on top that can have solvents in it that can attack that plastic. And that is very likely one of the issues I had when I put primer on this. I had a terrible problem with that primer being sticky and not drying when it should have. But we'll get to that. After I finished mixing this, I ended up with a consistency somewhere between pancake batter and peanut butter. I finished with a 4:1 ratio by volume. I think it should have gone to 5:1. I think just a little bit thicker would have been better. But after I spread this on here, it went on really easy. I was really happy with how well it went on. It went on way better than that tooling putty did. And that tooling putty left a lot of pores behind that had to be filled. This fairing filler for the epoxy went on very smooth. I didn't have an issue with leaving lots of pores behind. I think if you mixed it really dry, you probably would have that problem. But at least with the consistency I had here, it went on smooth, no problem. I was very happy with how it went on. Oh, and by the way, anytime you use an epoxy filler, whether that be Cabosil or micro balloons or this kind of plastic filler, make sure you wear a good dust mask. Almost all of those fillers like to float in the air, and breathing that stuff in is not good. So anytime I'm using one of these epoxy fillers, I'm always using a dust mask. That epoxy is cured, now let's take a look at it. I had a little drip here that you can see that ran just a little bit, and then I had just a little bit of sagging over here on this other side. So I think just a little bit of thicker would have been better. The sanding block I'm using here is one that I made myself, and I made a video of the construction of this sanding block. It's a flexible sander that I called the Kirby Sander 12. And if you'd like to see the video of the build of this sander, I'll put a link up here in the upper right hand corner. Sanding this plastic filled epoxy was very, very satisfying. The grit that I had on this sanding block was 220 if I remember correctly, and it sanded pretty fast and pretty easy. It took no time at all to do an initial sanding of this plug extension. It needed more after I did it, but this initial 220 sanding, quick and easy. To wipe this down, I used denatured alcohol. I think water probably would have been fine. I just like denatured alcohol because it evaporates faster and I can go on the next step a little bit sooner. The denatured alcohol shouldn't have a problem with this plastic. It's where you'd run into problem is if you use something like acetone. Then you would probably be attacking the plastic that it's in the filler, and that could probably cause you some problems. Here's where I made one of my mistakes. I'm using some primer, light gray primer, that I got from Home Depot. I wanted to do a little experiment and see how well this primer compares to the more expensive stuff I did on the plug. Unfortunately, I had not read the instructions on that lightweight plastic filler that I had used, and I had not known that solvents can attack that plastic. And looking back on it now, I'm thinking that solvents in this spray can paint, this primer, probably attacked that plastic, and it ended up making it a little bit gummy. We'll talk a little bit more about that later. But on this first coat, what I was trying to do is just put on a very light, tacky coat so that the following coats would stick a little bit better. Once I got this very light coat on and only let it dry, I don't know, 5 minutes or so, didn't really take much time. Then I put on a wet coat. I put this one on fairly thick. It was shiny when it went on. The first coat wasn't really shiny when it went on because I put it on so thin. This second coat that I put on is shiny when it's wet. So I put it on pretty thick. Now I let this one dry long enough to where it wasn't shining anymore. It had gotten tacky. So then I put on a third coat, and this is again a third wet coat. Now one of the drawbacks doing this, putting such a thick layer on, is it's going to take a little bit for it to dry out, for it to cure out. And I knew that, so I ended up waiting 24 hours before I did anything with it. And then once that third coat had dried, that was probably, half an hour later, maybe an hour later, I came back and put on a dark primer coat. And this is kind of a sanding indicator coat. As I'm sanding, I want to make sure all this dark coat disappears. And that lets me know I've at least sanded down through into the third coat of the light gray primer. Or if I've sanded down to where I'm starting to sand down through all three layers of this light gray primer, but I'm still seeing a few places where there's dark primer, then I know I've got an uneven surface and I'm going to have to put on more layers. Or if it's really bad, I'm going to put some more filler in. And then I made my second mistake. I've got my little spray booth in one half of my garage. Now when I did this spraying, it was about 75 degrees and about 45% humidity in my little temporary spray booth. But the fumes were pretty bad. It was getting late, and I didn't want fumes to get into the house. So I cracked open the garage door a few inches. That was a huge mistake. It was humid outside and hot. I came back out in the garage probably an hour later and looked at my temperature and humidity. I had 80% humidity and about 85 degrees. So that warm air came in, it cleaned out the fumes fine, but it made it really humid. Now, again, I didn't know it at the time because I did not bother to look at the instructions on the primer can, but that primer is only supposed to be used in humidity conditions up to 65%. So it had already cured a little bit by the time I let that high humidity in, but not enough. So that's probably a second reason why I had problems doing wet sanding later on this primer. What you're looking at here is my first indications that I've got a problem. This is the first sanding that I did on the plug extensions. I'm using some 320 grit wet and dry paper. And you probably noticed it earlier when I turned over that sanding block, but there were shiny spots on it because it was getting clogged. That surprised me a little bit. I knew it was possible, but I thought, this doesn't seem right. And even just picking up the part and feeling it, it felt just a little bit sticky. So I thought there's some kind of problem here. There's plenty of time has gone by. It's been around 24 hours or so. So this really should be dry. So I've got some kind of problem. I went ahead and forced my way through and went ahead and did an initial sanding on this. And at least I got some sanding done, even though it took a long time and I had to change papers a few times. The next morning, about 12 hours later, we had 12 hours more of drying, and in this case it was 45% humidity, so that was at least better. I decided to do some wet sanding, and I decided to use 400 grit wet sanding. I thought surely this is dry by now. Well, it may have been dry, but it still had an issue. I was still clogging up the paper even though I was doing wet sanding. Now, it wasn't 500 grit, it's 400 grit, and it wasn't clogging it horribly, but it was still clogging it a little bit. So, boy, this was disappointing. I thought I got a real mess on my hand. I may have to get some really rough sandpaper and just remove everything on here. But I thought, let's just give it a chance. Later that day, I was going to drive down to the ACCA, the Aviation Content Creators Awards. And so it was going to be several days before I got back and I was able to work on this again. So I decided to just try to finish wet sanding if I could, and then just come back and take a look at it again. And by the way, I did find out something interesting on this particular instance though. Using my spray water bottle that I use to keep things wet, if I sprayed hard enough on that sandpaper, it would actually peel off the gunk that had adhered to the sandpaper. So that actually helped me keep going and keep reusing the same sandpaper. I just spray real hard and spray off the clogged gunk layers on that sandpaper, and then I could keep going. So that helped a little bit. So after I got back from ACCA, I decided to go ahead and put 3 fresh coats of primer on. I thought that previous coats had plenty of time to dry, cure, whatever it needed to do. I didn't do any more sanding on it to actually see if it had dried. I decided to just go ahead and put 3 more coats on. And this time I was not going to open the garage door. I was going to leave it closed, and this time I had about a 45% humidity. So I decided to just leave it as it was, let it dry at 45% humidity, and let's see what happens. I did run into a little issue. I ran out of light gray primer on my 3rd coat. So instead of having the 4th coat being a very light guide coat, I decided to make that guide coat be really heavy. So I put a thick, dark primer on for the last layer. I decided to try to let this cure 24 hours before I decided to sand it. Well, I got a little anxious and I only waited 12 hours. I thought, well, I did a great job of keeping the humidity down this time. Surely it's ready to sand. So I started sanding on it within about 12 hours. It turned out it was better than the previous attempt, but still just a little bit sticky. In other words, with this 400 grit sandpaper, using water to wet it down, I still got a little bit of buildup on the sandpaper. Not as bad as the first time, but still just a little bit. I'm guessing if I had waited 24 hours, it probably would have worked out all right. Once I got done sanding it, I took it inside and set it on a little rack to let it dry out. But I mishandled the big one and dropped it. It landed right on the edge of the leading edge and chipped off a big portion of the primer. As you can see in this close-up, there's a little area on the leading edge flying surface that's chipped off just a little bit, and there's an area on the end plate right next to it, adjacent to it, that's also chipped off. Now in the future, and possibly even before I finish assembling this airplane, I'm going to have chips I need to repair. So I thought this is actually a good opportunity to do a little experimenting to find at least one way that I might be able to do chip repairs. The way I decided to do it is to use 5-minute epoxy, because that should hopefully speed up chip repairs, and use again some of this West Systems 410 filler, this lightweight filler, just to see how well it'll work for that. I think it'll work pretty well. I didn't want to have to do a whole lot of sanding on this chip repair. I'd like the future chip repairs to be fairly good, not requiring a whole lot of work. The way I decided to do this one is to put a little dab of the filler right there on the leading edge, and then use some packing tape and stretch it semi-tight around that leading edge so that that filler would form to the shape of that packing tape, which should be pretty close to the shape of the surface and not require hardly any sanding. And I also made the edge of that packing tape right at the edge of that end plate. Then I could put a little dab of filler right there on the end of the end plate where its chip is, and to just scrape off any excess with my stirring stick. That seemed to work pretty well. It got it fairly close. I also had a few areas near the outside end of the plug that really didn't get filled good enough. Since I had plenty of excess filler, I decided to go ahead and scrape a little bit on there, and then after it cured, I'd sand that off, and that'd make it a little bit smoother out there. After curing for about 12 hours, it was time to check out this little chip patch and see what it looked like. I peeled off the packing tape. That was the first step. It came off in several parts, but that was all right. I chose to use some 320 grit sanding paper and to sand this dry. I didn't want to get too aggressive with it because it was a fairly small area that I was going to sand. At least that was my intention initially. I decided to sand the end plate first. What I would do is sand a little bit, and then feel it, and sand a little bit, and the epoxy with the filler was just a little bit proud of the end plate, so it took a little bit of time to sand that down fairly flat and get it flush. I did the same thing with the nose surface. It was a little bit proud also. I was a little bit disappointed that the packing tape didn't do a better job of making my epoxy with the filler conform closer to the surface. It was still a little bit proud, so I still had to sand that down. After I had that done, I decided to go ahead and do a little dry sanding on this extension for the plug with this 320 grit and just see how well it sanded. It sanded great. Didn't have to have it wet. It didn't clog up the sandpaper. So this second application of the 3 coats of primer just needed enough time to cure. And then it sanded fantastic. Then it was time to go back into my little temporary paint booth and put on one more really wet layer of the dark primer. And hope that this is the last layer I have to put on. But the next wet sanding will let us know. It ended up taking about 2 days before I finally got back to working on this part. Here I'm wet sanding it with 400 grit sanding paper. It's amazing how much 400 grit can remove. It really removed a lot of this primer fast. But there was only one coat, so I shouldn't be too surprised at that. But I quickly worked through this last layer of primer fairly fast in a number of places. But even with 2 days of drying at fairly low humidity, about 45 to 50%, there is still just a little tiny bit of tackiness to this primer. I could remove it fairly easy from the sandpaper just by spraying it, but it's really annoying that I'm still having a little bit of tackiness issue. It's possible that still some of that filler that's kind of leaking through or soaking through because the solvent in that primer, I just don't know. I'm going to have to do another experiment where I use something like a water-based primer on top of that plastic filler first and see if I can tell a difference. So I'm not ready to say that this rattle can primer I got from Home Depot shouldn't be used. It could be that I just screwed up. When I finished with the 400 grit, I went up to the 800 grit and sanded all over with 800 grit. I then went up to the 1500 grit and sanded all over with that. And as far as gumminess and clogging up the sandpaper goes, the 800 grit worked fairly well. It gummed up just a little bit more than the 400. The 1500 gummed up quite a bit more. By the time I was done, the sheet of paper was roughly halfway gummed up. I probably should have swapped out and got another sheet, but I wanted to see just how bad it would be. I stopped sanding with this 1500 grit though. I had 3000 grit. I decided not to go ahead and do 3000. I want to see how good a finish I could get with this 1500 and then do some polishing on that. I need a way to hold these plug extensions to the ends of the plug. The way I decided to do it is with 2 screws. I could try to use some really long screws that go from this foam end all the way through and then into the plug. I decided not to do that. I decided to just countersink 2 holes down through the foam down to the plywood that's the end plate of the plug extension. I'm using a Forstner bit to do that, which is really nice because it makes a nice clean bottom to the hole right at the plywood top. And then the very center of that Forstner bit has a little sharp area that kind of makes a pilot hole for the hole that I want to drill on the way through the plywood. So I drill 2 holes in each of the extensions. I had to find some way to hold the extension right up to the end of the rudder plug while I drilled my holes, the matching holes between the 2 parts. What I decided to try was packing tape. I wrapped packing tape around the trailing edge and around the leading edge, so that would really hold it both vertically and horizontally to keep it from moving while I was doing the drilling. I didn't have to do it all the way around. Tape around mid-cord wouldn't really have helped me much. The rudder plug already has a really good release coat on it, a permanent release coat. And I was a little bit concerned that this packing tape wouldn't stick to it very well, but it stuck far better than I really thought it would. I was really pleased with that. Of course, it stuck even better to the plug extension because there isn't any sort of release on that. But amazingly, at least for this task, it worked pretty good at sticking to the rudder plug. Now this long drill bit I'm using here is pretty small. It's small enough that when I stick in the screw into the end of the plug, it should bite into that plywood that's in there very well. Now I'll make the hole that's in the extension that the screw will go through just a little bit larger so that the threads just barely touch, so I can keep that extension in place. But the screw will bite into the plug. And here all I'm doing is reaming out those 2 holes at the end of the plug, just so that that screw will not bite into that wood. That hole is just barely big enough that the screw will stay centered in the hole. I put off polishing until I was pretty much done handling the extensions. I was trying to avoid adding any little extra scratches. So now we're at the polishing part. Now these parts are pretty small, so I just decided to do this by hand. And like I said before, I stopped my sanding at the 1500 grit, and now I'm wanting to see how well this polishing is going to shiny up that surface. Now since I didn't use that power polisher, I don't really have a good indication if I did an equivalent amount of polishing. I can tell that it's a little bit less shiny than the plug was. Now that could be because I just didn't polish it enough, or it could be that there was a difference in ending with the 3000 grit versus the 15,000 grit. I really can't tell at this point. But the medium that's used in the polish sure makes it look shiny. Before I could apply the sealer coat, I had to wipe off all the residue from doing the polish, and I decided to use denatured alcohol for that. This is just ethyl alcohol. We're in the home stretch now. This next step is to add some Freecoat mold sealer. This just helps to seal up the pores. It kind of soaks in and prevents anything else you put on from being able to soak in. And it, like I said, it'll just seal up really small pores. It won't really seal up scratches, although it will kind of fill in the sharp corners or or the troughs or the bottoms of scratches. But it's a pretty thin medium, and so it doesn't really do a good job of filling in. I put on 4 coats of this sealer. If I remember right, it recommends 3. I ended up putting on 4, and I try to use a different stroke every time I put on a layer. For example, I might start with a circular stroke. The next layer might be a left to right stroke. The layer after that would be an up and down stroke or back and forth stroke. And then after that, I might do a diagonal, something like that. And that just helps make sure you get all of the surface covered. You won't accidentally leave some little nook or cranny uncovered with the sealer. Well, except for actually attaching this plug extension to the plug, this is the last step. We're going to put a permanent release agent on these extensions. The release agent I'm using is the Free Coat 700 NC. Now, I do have a little bit of an issue with this. This stuff is way past its shelf life. It's coming up on, 2 years that I've had it, and the shelf life, if I remember correctly, is 9 months, somewhere between 9 and 12 months, so it's way past its shelf life. I did some testing on it when I was making the plug, and it worked okay, so we're going to go ahead and give it a try, and hopefully it'll work. And I apply it the same way I did the sealer. I did 4 coats, 3 coats are recommended, and again, when I'm applying it, I use a different movement direction as I'm applying it for each coat. Oh, now we're down to the final step. I have screws with washers on them that I am putting down those countersunk holes that I put into the foam. And now they line up perfectly with the holes that are in the rudder plug. Just screw the plug extensions to the plug. We have the top plug extension and bottom plug extension now attached to the rudder plug. Let's take a look at what we got here. When I was in CAD and laying out the templates for these plug extensions, I deliberately made them a little bit smaller. I removed a 30 thousandths all the way around. I want to have a deliberate step between the plug and the plug extension. And I want that step to show up in the mold. Now that step will tell me exactly where I need to cut off the carbon fiber when I make carbon fiber parts, because that step will show up in the carbon fiber. So I will sand right up to where that step is. Before I get into the lessons learned on this video, I want to thank our Patreons for the channel. You guys are great. We're getting fantastic comments on the channel that people are learning things that they hadn't learned before. People who have been in the composites industry for quite a few years are learning new things. So that's fantastic, and you guys are making it possible. Well, now let's get into some lessons learned. We'll start with doing the fill on the foam. In order to fill that styrofoam, this time I used a really thin coat. Previously I put on a really thick coat and then sanded it down until I could just barely start seeing the pink show through. This time I put a really thin coat on, except for where there were some deep depressions. Then I went ahead and filled it in more with that sheetrock mud. And that worked really well. It was way faster, and I liked it a lot better. What I had to do though, to compensate for not having as smooth or fair surface, I had to wait until I put the fiberglass on and then do more filling on the fiberglass. Well, this time for filling, I used 2 different things. First, I tried this tooling dough and decided it was really too dry. You couldn't get a nice smooth finish just from the squeegee of putting it on. The next thing I tried was this West System 410 that is a filler for epoxy. I really like that. That went on really well. It sanded really well. There is a drawback to it though, and you have to be careful. You have to put some kind of a coating on it before you do any coating that has a solvent in it, because solvent can attack the plastic in this filler. And I think that's where this Stewart Systems Eco Prime will come in. This is a water-based primer, and it should not attack the plastic in this filler. Now, I did not do that in this video, but the next time I go and do a plug, I'm going to give that a try, and I think that'll work out pretty well. I don't know yet what to think about the primer that I got from Home Depot in the little rattle can. It could be that the solvent in that primer interacted with the plastic in here and caused a problem, caused a stickiness or substance that caused problems when I tried to do the wet sanding. Or it could have been too much humidity. Now, I think I pretty much ruled out the humidity issue with the last 2 layers. I had low humidity, well, medium humidity, and waited plenty of time for it to dry out. So there's either a problem with that primer or there's a problem where it interacted with this filler. So the jury's out on that. Well, the next thing to do is part 3, and you're kind of seeing part 3 right here, where we put our plug and plug extensions down on a little holding mechanism, and then we'll lay up our mold fiberglass over this. That'll be part 3, and as you can see, I'm working quite a ways along on part 3, and that should be out before too long. See you then.